Alright, so we're going to talk about the ever-dreaded distance formula. Everyone seems so scared of the distance formula whenever I bring it up, or when I say, what is it we need to work on to get you to pass this test, or feel comfortable with this test if you haven't taken it yet. Every time someone says the distance formula, you do the pre-test, we don't answer the distance formula questions. We're just generally scared of them for some reason. So today we're going to cover this in a video. I'm going to start with just pointing out, so when I say the distance formula, everyone kind of draws a blank or just stare at me. If I ask them what's the Pythagorean theorem formula, or Pythagorean theorem, they can usually shoot back really quick. It's a squared plus b squared equals c squared, and they'll tell me how comfortable they are, and they remember this in geometry, and they wish this was on the test and not the horrible distance formula. Well, in reality, they're siblings. They are doing basically the same thing, but using the distance formula, we only need the 2 points. We don't need to draw this graph that I have on the screen and we're about to use. And I'm going to show you both ways. I'm going to show you using the Pythagorean theorem, and I'm going to show you using the distance formula. So I'm going to go ahead and write the distance formula up here, just so you kind of have a second to look at it while I'm doing other stuff for the rest of the video. Never draw the radical long enough. Okay, so that's our distance formula. And like we said earlier, this is the Pythagorean theorem. And everyone right now usually wants to use this. So let's jump right into it. And we're going to graph these 2 points. We have 6, 2, and 0, negative 6. So we're going to go out 1, 2, 3, 4, 5, 6, 1, 2. Pretty clever. We already had the graph already. Now we have 0, negative 6, so we're not going anywhere on the x-axis. 1, 2, 3, 4, 5, 6. So now we're going to say, well, all you have are 2 points. That doesn't help us. Well, what if we were to draw a triangle here and connect each of these? I'm going to do this dotted because, that's really C, and that's what we're not going to have because we're trying to find the distance using the distance formula here. Alright, so what do? I don't understand this. Why does drawing a triangle on here matter? Well, we're going to count 1, 2, 3, 4, 5, 6. Well, that gives us the distance of A, 6. Now we're going to start here and go 1, 2, 3, 4, 5, 6, 7, 8. Well, that gives us the distance of B. So now we have from a squared plus b squared is equal to c squared. We now know that a is equal to 6, so we need that squared, plus b, which is 8 squared, will give us the length of the hypotenuse. So we're going to have 36 plus 64 is equal to c squared. 100 is equal to c squared. Let's take the square root of both sides, and we're going to have c is equal to 10. That's a lot of work. It's easier to remember, I suppose, when you don't practice it, because it is only 3 terms, and it's a simple equation. But do you really want to spend your time on the test when you have 2 minutes per question, drawing all this out and doing all this? You know what we could have done, and it would have been so much simpler. Well, so much faster if you remember the formula, which I'm pretty sure they give it to you on the test. So it's not one to hunker down and study and try and burn into your brain before you go, because they're going to give it to you on the reference sheet. So why don't we learn to use it properly and quickly? So if we look at it, we have a couple things: x2 minus x1, y2 minus y1. Well, there's no secret here. This is your x value, and this is your y value. Here's your x value, and here's your y value for each of these. Which one's x2? Which one's x1? Which one's y2? Which one's y1? Totally up to you. But make sure once you designate one as sub 2 or sub 1, you're always using that one for the other point. If that sounds confusing, let's just say I'm going to choose, even though this is the first x, I'm going to call you x2. So that automatically means we have here x1. This one has to be y2, and this one has to be y1. Your subsets, your sub numbers, the ones that identify which point you're taking them from, have got to be the same, but they don't have to, the order doesn't matter. I'll show you why in a minute. So we're going to say x2 minus x1. Well, we have 6 minus 0 squared plus 2 minus, and here this one's real tricky, negative 6 squared. We need the square root of that. So we're going to go ahead and work according to order of operation inside here. We're going to have 6 squared plus, and now we're going to distribute this in, so we're actually going to end up with plus 6 or 8. Well, look where we're at right now. I believe when we just did that whole long roundabout way, we ended up with the base and the side, or the leg, being 6 and 8. So we've already jumped over that whole graph, that whole hurdle of doing all that. So all we really have left to do, and we have the whole square root here, is square this, which is 36 plus 64. And we need the square root of that, which really gives us 100, and the square root of 100 is 10. So D is equal to 10. Same answer, 2 different methods. You're going to have this formula on the sheet in front of you at the test. I would recommend using it. It's quicker, it's funner. You feel more accomplished doing it because you start off scared of it a lot of times, and now you're using it with no problem. Let's do a different one. And you're not going to always get nice whole numbers back, so using either method, don't think that the Pythagorean theorem is always going to give you the same either. Let's do the same as in a whole number. You'll always get the same answer if you do them both correctly. 20 negative 10 and 8 6. Alright, last time I did 20 as my x2. I'm going to do it as my x1 this time. y1 x2 y2. Alright, so I need x2 minus x1 squared plus y2 minus y1 all squared, and we need the square root of that. We're not going to forget to remind ourselves that what we're figuring out here is the distance. So here I'm going to have negative 12, and here I'm going to end up with plus 10 to give me 16 squared plus squared square root, and D is equal to this because we're finding out the distance. Well, negative 12 squared is 144, and 16 squared is 256. Let's add those together. And what do we have? 400. Oh, what's the square root of 400, everyone? 20. It is not the square root of 20. It is straight up 20. Let's not get ahead of ourselves or start worrying about what I'm going to show you next. Cool. So does it really matter? I said it doesn't, whatever you assign these. So let's show you why it doesn't matter. So you're no longer the same things you were given before. So now you're going to be x2, and you're going to be y2, and you're going to be x1, and you're going to be y1. And we're going to solve this one in this funky purple. Let's go ahead and just rewrite the formula. I'm going to leave it, of course, the variable portion blank. So last time we had 8 minus 20. Well, this time we're doing x2 minus x1, so we're going to have 20 minus 8. And therefore we have to have y2, which is negative 10 minus 6. And we're going to keep doing the problem right on down like we did before. Well, we now have 12 squared plus negative 16 squared. Well, look at the similarities here already. Where we had negative 12 in the first one, we now have a positive 12. Where we had positive 16, we now had a negative 16. Well, how's that going to affect our answer? Is it? It will not. This is why I said it doesn't matter. As long as you keep the subset 2 together and the sub 1s together, you're going to end up with the same answer every time. Having 12, anytime you're squaring a number, you're always going to be positive. So just make sure you do them in the way that you're most comfortable. I prefer that my x2 is always on the first point listed and my x1 and y1 are on my second point listed. It's personal preference. I'm not going to say it's better. It's just what I've done. Maybe because I was a little bit of a rebel in middle school. I don't know. So now we have 144 plus 256. That's still going to lead to the square root of 400. There's the rebel coming out again. And my distance, again, is 20 units. So it doesn't matter. Go with whichever way you prefer labeling them. Go with the Pythagorean theorem if you want, but do you really want to spend your time on the test going out 20 points and then down 10 and then out 8 and up 6? That's a huge triangle. That's so much of your board that you're given wasted. And it just, I wouldn't do it. I couldn't do it. My nerves would get to me. This is really these are really questions where you should bank some time for those harder ones, the ones that you're going to struggle with a lot. A lot of times it's the algebraic word problems where you really need to put the money in the bank or the time in the bank. All right, so we're fortunate enough on both of these to have two nice whole numbers. So now I'm going to give you one more, and it's not going to come out so nice. We're going to have the points -3, -1, and -4, 0. Like I said before, let's go ahead and draw this out so we don't miss anything. And my favorite thing to leave out, showing that we're finding the distance. Well, my x2 is here, so I'm going to do -3 minus -4, and I'm going to do -1 minus 0. This one already looks interesting, so we're going to actually have +4 here. So let's cross that out. I write it as +4. Well, -3 plus 4 is 1. I'm going to square that. And here we have a -1 squared. Oh, that is just 1 plus 1, which gives us a final answer of the square root of 2. You do it now, but have this be your x1 and your x2. See if you get the same answer. I think you already know that you will.